right, by way of introduction, the next presenter is Dr. Kevin Knuth. He's the Associate Chair of Physics. As you can see, the location at SUNY. Also, besides what's on the chart, he is the Editor-in-Chief of Entropy Journal, Editorial Board of Axioms Journal, amongst others. He also served as a research scientist in the Intelligent Systems Division at NASA Ames Research Center. His research areas are quantum mechanics and physics, relevance and maximum entropy, and a high-quality Bayesian data analysis. And with that introduction, Kevin, I'll turn it over to you and look forward to what you have to say.
All right, thank you very much. Great, thank you very much for that kind introduction, and thank you for the organization as well. So my name's Kevin Knuth, and I did this work with my colleague, Professor Matthew Shadagas, also at SUNY Albany, and David Mason, an engineer who we're working with on the UAPX project. Next slide. So the scientific collection of data on UAPs is underway. We have the UAPX group, which was formed by Senior Chief Kevin Day, who you can see in the middle here. Senior Chief Kevin Day was on the USS Princeton in 2004 during the Nimitz encounters. He was the one who was actually tracking these things on radar. So we have a good team of people from the Navy and Air Force, along with physicists, and we've actually been active collecting data. Next slide, please. We all became aware of the ATIP program, the Advanced Aerospace Threat Identification Program, which was run by the Defense Intelligence Agency in 2017, in the New York Times article. And one of the useful outputs from that program is the list of the 5 observables. We have positive lift, sudden, or they call it instantaneous acceleration. I'll mention that in a bit, and hypersonic velocity without signatures, transmedium travel, and low observability or cloaking. So this talk is going to focus on these 5 observables, as well as some other physical characteristics that we've observed. Next slide, please. So I want to reinforce the understanding that the vast majority of UAP are misidentifications of astronomic and atmospheric phenomena or conventional aircraft. And another large proportion are hoaxes. That is not disputed here. It really comes down to only about 3% of reported UAP are of interest, and a subset of those appear to be anomalous unidentified aircraft. And these are the ones we're especially interested in. Next slide. So here's an example of mistaken identity. This was a photograph taken in Vancouver, and the flying object in the photograph was not seen by the photographer. This is very typical when this happens, and was seen only later. And it can be identified, next slide please, as a seagull. If you blow it up and compare it to seagulls, you'll notice this. I recognize this right away because I'm a lifelong bird watcher. So for me, it was obvious it was a seagull. Maybe not obvious to everyone. Next slide, please. Also, some images are altered. Here's an image of a purported image of a UAP, triangular shaped or boomerang shaped UAP. As an astronomer, I recognized immediately that the stars are not real. And you can then hypothesize as to what else might not be real in this image. So we don't need to go into details. Next slide, please. So some UAP have been partially identified, and I'll use that phrase, partially identified, as structured craft. That means we have descriptions of the object, sometimes detailed descriptions, and but we don't have any frame of reference with which to compare them. And these are the cases that are of extreme interest to us. Next slide. And so now I'll go into the 5 observables and other physical observables, looking at some examples. Next slide. So positive lift is the first one. And on the right here, you see a video, a short clip from a video taken by US Homeland Security in Aguadilla, Puerto Rico in 2013. So you have this object that flew over the airfield in Aguadilla and then headed out over the ocean and eventually went into the water. The object was estimated in size after analysis was performed by the people at SCU, the Scientific Coalition for UAP Studies, and you'll hear from Peter Reale on another case coming up. The object was small, a small football-shaped object. The important points here, scientifically, are there are no apparent lift or control surfaces. It's unknown how lift was generated in this case, and unknown how the object propelled itself. Objects like this, UAP, have been observed to be capable of flying and or hovering for long periods of time. When chased by jets, there are many examples where jets have chased these objects and run low on fuel and had to go back and refuel or replace, send up another jet instead. So the two well-known cases are the 1952 UFOs over Washington, D.C., and in 1956 over Lakenheath. And Ravi had just asked if I could show the previous slide. Can you go back to the previous slide quickly? There. I don't think I had any information there. Okay, go to the next slide. Thank you. And next. There we are. Yeah, so the last point on the previous slide was there's no heat signature. That imagery is from an infrared camera, and you don't see any heat signature from the engines or exhaust. All right, next slide, please. So another one of the 5 observables is sudden or instantaneous acceleration. By instantaneous, what they mean is that it's too high to measure. So the ATIP program talks about accelerations that are too high to measure, and we've looked at several cases and published them in this peer-reviewed paper that's linked to down below. And the accelerations we've estimated in those cases range from 70 G to over 5,000 G. Now, the case here that I've illustrated on the right is the one that Ravi was talking about from the Washington Post. Unfortunately, the newspapers mess up the numbers. The objects were tic-tac shaped objects, which were traveling horizontally at about 120 knots and would suddenly drop from about 28,000 feet to 0 feet sea level or 50 feet above sea level. There were various instances of this, and that would happen on the order of 0.78 seconds. So if you treat this as, if you want to estimate the minimal acceleration to pull this off, you would accelerate at some acceleration A halfway and then decelerate at the same acceleration the other half of the way. And that allows you to estimate the minimum acceleration observed here. And in this case, you can see from this histogram, we've accounted for uncertainties. So the height was 28,000 plus or minus 300 feet. And we put some uncertainty into the time as well. So we have a distribution. And you can look at the research paper to get more details on that. But you can see it's unavoidable for these accelerations to be less than 1,000 G. And 1,000 G is, as I'm sure you were all aware, absolutely insane. So what's going on here is truly anomalous. All right, next slide, please. So another characteristic, one of the 5 observables, is hypersonic velocity without signatures. And by that, there's no sonic booms. There's no air disturbances that you would expect from hypersonic speeds. So UFOs have been, UAPs, sorry, I'm using old terminology, have been tracked at hypersonic speeds in air, hypersonic speeds as high as Mach 55, which is about 42,500 miles an hour, were reported by Hermann Oberth, the rocketry pioneer, in a lecture he gave on UFOs back in 1954. When in estimating this case, we found that if you accelerate at 5,000 G down and then decelerate at 5,000 G, at the midpoint, you are traveling about 46,000 miles an hour, Mach 60. This is faster or on the order of the speed of the New Horizons spacecraft that recently flew past Pluto. Not so recently, 6 years ago, I guess now. So one may ask, why do people mistake these objects as spacecraft? Why do people hypothesize that these things are spacecraft? And the answer is quite simple. These things are moving as fast as spacecraft move. So the New Horizons probe was one of our fastest probes ever. And these Tic Tac objects had to be moving at least those speeds to be able to perform the maneuvers that we see. Now, what's shocking about this, even more shocking, is the fact that there's no energy deposition when these things decelerate or stop. So this drop maneuver, we assumed that the object had a mass of 1,000 kilograms, just to pull some number out. It's about the same size as an F-18. So an F-18 is about 1,500 kilograms or 15,000 kilograms. So we thought we'll go an order of magnitude less than that, about 1,000. And performing that maneuver, the amount of energy that would have been necessary would have been on the order of 4 times 10 to the 11th joules. So that's equivalent to 100 tons of TNT, or would have been equivalent to blowing up 250 cruise missiles, Tomahawk cruise missiles simultaneously. There should have been a huge explosion when this thing came to a stop at the sea surface, and that was not observed. Herman Oberth, and a little bit's cut off at the bottom here because of zoom. He wrote, their speed is sometimes very high. 19 kilometers per second has been measured with wireless measuring instruments, radar. Accelerations are so high that no man could stand it. He would be pressed against the wall and bruised. I would say that it would be worse than that, far worse. The accuracy of such measurements has been doubted. If there would only be 3 or 4 measurements, I would not rely upon them and would wait for further measurements. But there is existing more than 50 such measurements. The wireless sets or radar of the American Air Force and Navy, which are used in all fighters and cannot be so inaccurate that the information obtained, blah, blah, blah. You get the idea. So that's from Herman Oberth's talk in 1954. And it's a shame that 60 years ago, we knew this much and still did not proceed in the scientific community to study these things. That's 60 years of research lost. Next slide, please. Transmedium travel. UAPs can travel effortlessly in multiple media, from air to water, as you can see illustrated here on the video on the upper right. This is again the Aguadilla, Puerto Rico case, and this is after it's headed out to sea. And you can watch the object will actually travel underwater. The graph below is from the report produced by SCU, the Scientific Coalition for UAP Studies, and they show that the object enters the water around 110 miles an hour, and once it's submerged, it's traveling at about 100 miles an hour. Those are their estimates. So and then continues through the water around 85 miles an hour. So you don't have a very dramatic speed decrease as this object enters the water. I mentioned here space and vacuum. The senior chief Kevin Day on the USS Princeton said that the radar operators who were there for tracking missiles coming in from space, like intercontinental ballistic missiles, had tracked these UAPs coming in from low Earth orbit before they got to the 80,000 feet that his radar was able to pick them up at. So, but none of those radar operators have come forward to talk about what they observed. So I have that in red. And then I asked the question, these things have moved from air to water effortlessly. Can they move through solids? There are almost literally a handful of cases where people claim to observe this, although nothing definite. Next slide, please. All right, low observability or cloaking. So this is the same object in Aguadilla, and you watch as it's flying over the city here, it'll actually dramatically change size and almost disappear at some points. So it's not clear exactly what's going on, but the UAP are observed to do that. Sometimes this activity seems to be intentional, as if they're trying to hide, and sometimes it just seems to happen. Next slide, please. Another effect is a plasma sheath. UFOs or UAPs are sometimes surrounded by what appears to be a plasma sheath, a glowing plasma around the object. It's often one source of the emitted light from these objects. The plasma and heat would tend to make images blurry, and so very often UAP imagery is blurry. Also, not everyone is a great photographer and able to photograph under stressful conditions like this. So here in the upper picture in the upper right, I have a picture from the US Navy gimbal video, and you can see the object there. And I'm comparing it to another image that was taken by Ray Stanford back in 1985. And this was a multi-witness event from Corpus Christi, Texas, where several of these objects they're disc-shaped objects were seen to be moving across the screen or across the sky. And he filmed this with a Super 8 camera. I want to be clear that that imagery here has not been independently vetted. So we've not taken that to be authenticated. And so I want to be clear and honest about that. Although I have talked to people who have seen it and seen it in person. And Christian Lambright is one such person who was able to view the video or the movie just a few months after it was recorded. So we found that this is really interesting, first because it demonstrates the plasma sheath. You can see this blue glow around the metallic object. The shape of the plasma sheath is interesting because it looks very similar to what you see in the gimbal video. And one other feature here is if you look at the blue picture in the lower right, you'll see the cone-shaped object. So it's a disc-shaped metal disc with a blue plasma glow around it, and around the point of that plasma glow, you'll see a thin line of a thin blue line coming off of it to the right. Hopefully that shows up on Zoom, and I'll mention that on the next slide, please. So one technique now used to achieve hypersonic speeds in air is to use a laser beam to basically create plasma in front of the craft, and the plasma creates a shock wave that actually goes around the vehicle, and this allows the vehicle to plow through the air at higher speeds. So this is a technique that's currently being worked on. And next slide. And this is what appears to be happening here. And in fact, this is what Ray Stanford claimed he saw, is that he saw the plasma beam would come out from the plasma glow around the disc, and then the disc would fly forward toward the beam. What was interesting is that he notes that the discs that he's observed fly basically, they hover like this, like you would expect in an aerodynamic fashion, but when they're ready to fly, they actually tip up and fly bottom forward, which is not what you would expect. You would expect it to fly in the most aerodynamic way possible. What's interesting is that Herman Oberth mentions this as well in his 1954 presentation. He writes, "The discs always fly in a manner as if the drive is acting perpendicular to the plane of the disc. When they're suspended over certain terrain, they keep horizontal, and when they want to fly very quick, they tilt and fly with the plane directed forward," and so on. So next slide, please. And back to low and we're still on low observability and cloaking. In addition to fading away and disappearing, changing size, these objects are often appeared to split into multiple objects. So you can see in the sequence of imagery that I got from the Aguadilla video, down by the bottom, it appears that you actually have two objects. This, of course, now in some cases this can happen very rapidly in many multiple images a second, so the object can look blurry. This also contributes to blurred photographs. And so if you take photographs, you want to photograph at a very high speed.
2 minutes.
Next slide. Thank you. Next slide, please. So here's another example of multi-imaging where the object appears to break into two. And sometimes these multiple images can be at different orientations or different views of the object. And so it can be a subtle effect or very dramatic, as in this video here from the Puerto Rico. All right, next slide, please. Also, sometimes you get a volume around the object in which the background imagery appears distorted. So I'll call that a distortion field. And you can see that here, especially when this object flies over the lines designating parking spaces. And the question would be raised, is this optical refraction due to a varying index of refraction? Or do you have distortion in lensing due to a gravitational field? These are two hypotheses. There are probably more hypotheses one could come up with. And next slide. Another physical effect is low temperature. As Ravi noted in his talk, you would expect these objects to generate waste heat, and they very often do not. And so this is very surprising. This is a go fast video, and the object may not be going very fast. It's been, as has been claimed, it's called go fast because it looks like it's going fast, right? That's probably the most impressive thing about the video. However, what's interesting is if you look in the lower left corner, you'll see the letters BLK at the bottom. That means hot objects are black. This UAP is cold. It's white and it's cold. It's colder than the sea surface. So we've got a cold object that's basically cruising along the sea surface. So not a seagull. Seagulls are warm-blooded, warmer than the sea. This is a cold object, and it's not clear how that happens. And we find that in videos often. Next slide, please. This is a video that our engineer, David Mason, took. Then that was a jet airplane flying over that was hot. This is a UAP that's following it. We actually captured it in two cameras, so you're seeing both cameras here. Only one camera captured the jet airplane. So the UAP that's traveling has a temperature of about -60 Fahrenheit. So it's very cold, and it appears to be a trefoil shape. It appears to be three distinct objects. So it could actually be three objects flying in formation. So this, again, the bright object is warm. It's a jet airplane. And the object following it is about 60 degrees below zero.
Kevin, time's up.
Okay, thank you. Next slide, please. If I'm wrapping up, and we'll go next slide. Yeah, so one last really quick point is there have been some work on developing warp drives, some theoretical work. On the right, the diagram from the paper by Bobrick and Martyr shows the space-time structure around their hypothetical warp drive. And just coincidentally, it looks very similar to the gimbal video and the Ray Stanford picture. All right, next slide, please. And next slide, there's strong magnetic fields and conclusions. So thank you very much for the talk. These objects are sincerely anomalous. They are interesting. They exhibit numerous observable physical effects. It is possible to observe these things. Our UAPX group is actively studying them and collecting, and we're actually analyzing data at this point from a recent trip we took to Southern California to collect data on these things. So please visit our site at uapexpedition.org. And if you're feeling generous, we're accepting donations. So thank you.
All right, Kevin, thank you. We'll open it up to a little bit shorter than 5 minutes for question and answer. So let me turn it over for someone who would like to ask Kevin a question from the information he just showed.
Hi, Kevin. It's Chris from the Debrief, head science writer from the Debrief. Can you hear me okay?
Yes, I can. Thank you.
Okay. Near the end of your presentation, there was a side-by-side video of infrared footage of a commercial airliner or a military airliner. And then
right. That was a commercial airliner. Yep.
What was the origin of that video?
David Mason from our UAPX group recorded that from his backyard in Renton, Washington.
Okay. Thank you. That was my main question.
Thank you. It's one of the many videos that we've recorded at this point with the UAPX group.
Are there plans to make those videos public, Kevin?
Yes, after we've analyzed them and hopefully publish some of the data, we'll be making them public, certainly.
Great, thank you. Well, if no one's going to ask another question, Kevin, I did have one in the side chat there.
Oh, sure. I didn't
Ask
get a
if I-
chance to look at this chat.
If a balloon could be colder than the sea surface on the Go Fast video.
That's a good question. I'm not sure exactly if that would be reasonable. You would imagine that the sun hitting the balloon is going to heat up the rubber on the balloon and hence the air inside. So I can't imagine it being, it's not going to be less than the temperature of the air around it. At the very least, it would be at equilibrium. So you would have them be equal temperatures. And if the sun is striking it, it's going to be warmer.
Okay, thank you.
Yep.
Kevin, I'll ask a question.
Sure, thank you.
On the chart that you had, which showed the object changing shape,
Right.
this may be what I call SOTO, statement of the obvious, but I'm going to assume that the origin of the object that was tracking that object stayed in the same relative distance, so there was not an effect of close up, far away. Would that be a correct statement?
Yeah, I think that's correct. Over the time scale that the object changes shape, I think it was being filmed from a helicopter. That was not dramatically changing its perspective. It was sufficiently distant.
Thank you. Other questions for Kevin?
Hi, can everybody hear me okay?
Yes, go ahead.
Yes, Matthew.
This is, yeah, Matthew Phelan. I'm working on a podcast on this topic for iHeartRadio. Kevin Knuth has
Excuse me,
dealt
sorry.
with me in the past. So I had a question about the issue of some of these speeds and accelerations being, essentially too high to measure, and I'd love to hear more of your thoughts on the threshold there. Essentially you have something like radar, that is pushing out EMF and getting EMF spectra back, and to what extent, like when does it start to fall apart in terms of we can no longer even say with certainty that it is the same object. It could be like two heated balls of plasma being produced by some electronic warfare. This is very hypothetical, I'm sorry, but
We have about 1 minute.
okay, so I yield. That's the gist of the question. Is
No, that's a
about
good
when
question.
in
It's
the
a good
breakdown of
question,
the-
and I don't think it's clear at this point. And many of these cases are very different. Some of those objects that we looked at in our paper were observed to be, one of them by Graham Bethune in 1951. We looked at the accelerations there, and that object was observed to be disc-shaped and about 300 feet in diameter. So they're very different than what you'd expect from a ball of plasma.
Thank you.
All right, Kevin, thank you so much.
All right, thank
We'll
you.
get out of share and go on to our next speaker. So give me 1 second, please.